I would like to welcome our first panel to discuss autonomy at war. Dan Gibbons, David Pine, and Brandon Singh from Shield AI. Please, everybody, come on up. Thank you. Yeah. No, I see here. Thank you for your concern. Okay. So Brandon is with Shield AI. If you don't know them, they're making some of the most important drones that are affecting the battlefield of Ukraine, and they're changing them at a very rapid pace. Dani Gibbons from Primordial Labs, I ran into them a couple years ago at a Special Operations Forces event. Army Rangers at the time, and now it's actually a uniform across the Army, had these little bug drones that you could throw up into the air and they would surveil. And what one of the things that Primordial Labs was working on is a voice interface. So you're an Army Ranger, you're downrange, and you can tell your little drone 40 degrees left, hover, etc. It's amazing. And David is at DIU, and his job is counter UAS. And that's incredibly important for this discussion of autonomy, because the way you traditionally counter drones is you jam them, you use electronic warfare, you just send signals so that the drone can't talk to the person. Right now in Ukraine, they're trying to fix this by basically having fiber optic cables. But autonomy, theoretically, you don't have a signal between the operator and the drone, nothing to jam. So it's a cat and mouse game in many ways. This is two autonomy and counter-autonomy accelerating at breakneck speed against one another. So let me start with you, Brandon. Talk a little bit about some of the most recent things that you've been discovering in Ukraine and in terms of what you make, the VBAT, and a variety of other drones, how you see that innovation cycle right now picking up in the future.
Absolutely. One, thank you for having me, Patrick. The innovation cycle is accelerating in a really massive way. So Shield AI, we're about 1,000 people. We're a venture-backed company, most recently valued at $5 billion. Probably most famous for being the first company in the world to fly the F-16 autonomously. We did the first ever AI-piloted F-16 versus human-piloted F-16 flights. And what we have seen, started the company 10 years ago, is just that iteration cycle. Again, massive acceleration. What used to take us $70 million and a team of 80 engineers, 2 years to put autonomy on a quadcopter, we can now put very highly advanced levels of autonomy on a jet aircraft in about 2.5 months with 2 engineers. Right? And this mirrors what everybody is seeing in the consumer industry with a ChatGPT or a Grok in terms of how it's enabling people to do more work, better work, faster. The same thing is happening in the autonomy space. And so what I think is also interesting about, you mentioned Ukraine and our work that is going on there. It's not just the speed of technology innovation, it's the speed and advancement of tactics, techniques, procedures on the battlefield. And I've been telling senior military leaders, like, tech is only one piece of a successful military operation. And with what happened over this past weekend in Iran, what I really admire, it's not that the B-2 is an incredibly advanced aircraft, right, that, went undetected, but it's the communications component, it's the logistics component, it's making sure the weapons work, it's the training of the pilots. All of that is what makes a military capability effective on the battlefield. We've seen tech on the battlefield we've seen our tech on the battlefield in Ukraine be used ineffectively, right? And it took time to train, to go through those cycles with the Ukrainians to actually make it an effective piece of technology.
So I want to move on to the other panels, but first I want to, on that, because I have we talked a little bit about a story that I think is incredibly important to understand how to be relevant as a defense contractor now and what is relevant to the future of defense right now. You brought some of these VBATs over, you were going to test them, and the Ukrainians were like, okay, we're going to jam GPS at a certain floor, and then after that, you should be able to fly. And what you found, right, if according to the story that I have and sources, in fact, GPS was just uniformly jammed.
Yeah.
So you sent that VBAT up, and it went something like 200 meters in the wrong direction.
No, it's a fun story. It's fun. It was super stressful when it was happening.
Yeah.
And so we went out to Ukraine. In 2023, our AI pilot was not integrated onto the VBAT. Went out to Ukraine with a bunch of other drone systems purchased by the British. We told the Ukrainians, we told the British, hey, our AI pilot's not integrated on board. If there is jamming, it will fail. Lo and behold, it was jammed, it failed. We still wanted to tackle the problem, went back out in mid-2024. We told them, we're confident, we've integrated the AI pilot, it will work when GPS is jammed, communication is jammed. The Ukrainians told us we were the only company in the world to have passed their electronic warfare testing regimen, 7 GPS and communications jammers all on full power, within 100 yards of our aircraft that's flying overhead, no impact. They said, great, we want you to go prove it to us that it works on the battlefield. Really understanding that it's not just the technology, right? You have to have that full suite, the logistics, the comms, everything goes into making a capability. Right. They told us that it was not going to, we said, is GPS, what are the assumptions? Well, you will actually have GPS on initialization, up to, 500 feet, and then you'll probably lose it. Yeah. Really bad assumption. There was no GPS from the get-go. So what happened? Our aircraft takes off, and it's like a scene, if you've seen the movie, which I think most people have, Interstellar, right? And where Matthew McConaughey is driving through a cornfield, chasing down a drone in a truck. Exact same thing happened with our people out there. Yeah. They are chasing down this drone, 6 hours chasing it down, landed on a Ukrainian freeway. Yeah. Ukrainians were like, I told you, we didn't think it was going to work. We said, you know what? You gave us a bad assumption. We're going to.
And then in 24 hours.
They
went back. Yep. And they fixed the thing. They kind of reinvented the drone based on the battlefield condition. Yep. That's the sort of thing that used to take a very long time. You have a program of record, you got to figure that out. 24 hours. Took down, fixed it, back up.
Yep, 100%. Tested, validated software team in the United States, software teams in San Diego, Washington, D.C. working together, send it to the team in Dallas, Texas. Dallas, Texas goes out, tests, validate it, says, we got a good patch for it, send it over to the team in Ukraine, 24 hours, patch it. We tell the Ukrainians we want another run on it. We do the run, and we do the first ever long endurance ISR and targeting strike operation where we blew up a Russian SA-11 Bukovel surface to air missile system, a strategic capability of the Russians. Ukrainians had never seen anything like it.
That's a pretty good day too for a drone that, like yesterday, was getting smacked. So, David, let me turn to you, and then we're going to go to Dani. But when you hear this, when you hear about the ability to innovate around a counter-UAS solution in 24 hours, and he did it, but the entire Russian-Chinese military is working along similar lines. What keeps you awake about that? How do you think about that problem?
We were discussing this in prep, that specific question, and I told him that I thought about giving the quip from General Mattis, that nothing keeps me up at night, I keep others up at night, but it just doesn't land as well coming from me as it did from a man who led soldiers into combat for 40 years. So it's oftentimes referred to as a cat and mouse game. I actually like to think of the proverb of the lion and the gazelle. Every morning, the gazelle has to get up and run faster than the lion. Every morning, the lion has to get up and run faster than the gazelle. Regardless of which side you're on, every morning you better be running. And in this case, that is very true. Every morning, both sides have to continue to innovate. We know that on the offensive side. We know that on the defensive side.
Are we doing that now? Are we waking up every morning and actually innovating at the United States Department of Defense? I know some folks are, but is the department as a thing? Is it trying?
We absolutely are. So just last month, we launched 2 solicitations for low collateral defeat and lower cost sensing for counter UAS. We got literally hundreds of proposals from across industry. Some of those advancements are incredible. Yeah. And if my friends here are not innovating on the offensive side, those defensive things are going to catch up and be able to defeat their solutions. And we know on our side, there are other people on the other side who are trying to continue to innovate. So we absolutely are, but we know we can never get complacent and slow down.
So that's a really good point. And one of the things I love so much about Brandon's story is it emphasizes something very important, and that is the idea of like some person in Virginia that now like gets an order in about a malfunction, and so we're going to do a workup, and we're going to send an estimate, and then we're going to come back. You have to have a dude on the ground. You have to be on the ground with that person using that thing now. As a maker of the thing, you are now with the thing. It's the way Ferrari designs, like Ferrari will customize your Ferrari for you. Everyone gets their own very personalized Ferrari. It's not like, you send an order to some distant thing and they just punch it out mechanically. So Dani, let's turn to you because a huge focus of your entire company is actually being there with that warfighter as they integrate and as they develop a relationship with some of these next generation things. And so tell us a little bit about what you're learning right now when you work with Special Force or other folks in terms of the interface that they need to have with these machines to make sure that they're not just going off like clockwork, they actually understand intent, they can communicate and provide real value. What's the most important thing you're learning?
So there's a couple of different things. The first is really, you cannot be dependent on a specific hardware system. You have to be able to integrate and adapt across all of them. So we are doing more than just the little tiny quadcopter things. We have to be able to provide that voice recognition, that ability to just natural language processing across many different things. So we're hardware agnostic. We can work with any drone, even in manned systems. So the subsystems on a manned aircraft, be that a sensor, a radio, any of those different types of things. Anura can be that voice link to be able to command it without any other extra hardware. So it's amazing. That gives you the ability to control across all of these different venues in one space. And it does do that intent for you. And the way that we're doing that is really interesting because we're not trying to go out and, chat GPT it or anything like that. What we're doing is using sensor technology to break down the individual little tasks in each different thing. So if you say, go hover, what does that mean? Your drone has to understand what that means.
Yeah.
So you do that by breaking down those little tasks underneath and then giving it the ability to go do that.
Yeah, and so this points to something I think that's really important, which is when you're out there, because of ubiquitous jamming, because of electronic warfare being what it is, you're not going to have the opportunity for your drone to kind of reach back to a massive enterprise server cloud in Virginia or somewhere. I don't know why they're always in Virginia, but that's kind of where a lot of this stuff is. That intelligence has to be on board. That is a fundamental distinction from the way we're all experiencing artificial intelligence through ChatGPT. We experience big AI. Great big server, enterprise cloud capabilities, great big data sets, all smushing together, putting out to you this little exchange where it feels very personal, but it's actually just so much stuff behind it. The hard part is creating that intelligence on platform. So David, let's turn to you now, because as we're talking about these things, the issue of autonomy and how that defeats traditional jamming, traditional electronic warfare countermeasures, it seems kind of silver bullety, right? Like once you got the intelligence on board, that thing's flying dark. It's got its own understanding of space. They can take a picture of the ground, compare it to a picture that it has on board, find out where it is. How do you begin to defeat that if that is going to be the next generation of counter UAS?
Yeah, I think more broadly, it's like, regardless of which side you're on, if you think you have discovered a durable advantage in the age of autonomous warfare, you are wrong. It is going to be persistent for a period of time. That may be, if you're lucky, measured on the order of years, likely on the order of months, if not weeks, if not hours, or we're seeing some cases with autonomous systems where you have the jammer, which is rapidly switching frequencies to different protocols, all of that. Similar on the drone itself, constantly switching. And so you may be looking at minutes or seconds as this kind of battle is occurring between these two machines, which I will say on the defensive side is a source of potential advantage, because on the defense, you're generally going to have more power, more compute than whatever is coming at you. And so understanding as well what advantages you have from the defensive side versus the offensive side is important for both.
That's fascinating. So that's the conflict. There's a little civil war brewing within AI between the small AI, on-platform, high performance, no connectivity, and the big AI, the massive compute resources that can fling against it. How very Netflix. I love this so much. Dani, so you talked about this ability of the interface to begin to understand intent. But because you have access to yes, you can take all of the data that you're gathering from all of these people as they interface, as they talk to all these weapon systems, bug drone, 40 degrees left, missile, go get it. You can collect all of that and then use that to train the model. So this thing is learning.
This fast.
Yes. And so eventually it's going to know it's going to understand a lot of intent before it is explicitly verbalized. How do you see that acceleration happening? And is there a way to predict when that's going to result in some massive transformative thing where now it is, in fact, like you have the bug drone that can go out further in advance of the soldier, understand the entire thing better, and the soldier becomes basically the manager, and a lot of risk is removed. When does that happen?
That is the goal, and that's actually what we're chasing rapidly right now, is getting to the point where all of those are basically your co-pilots. And it's like you have another human co-pilot kind of there with you. They understand the battlefield. They understand the intent of what you're trying to do. And so you can just give a small command of go to this spot or, alert me to movement. And they will do that. And you don't have to explain why, how, all of those other things. And you can just then be that manager. The thing where that really changes is it gives you the ability to command far more different pieces of hardware, software, whatever, with one person.
Yeah. When does it begin to know in advance sort of like what is going to be asked from it? When does that sort of like changeover happen? Is that not the right way to think about it?
We don't think about it that way yet. I'm not saying you're wrong.
Right.
I would say the goal right now is to make it so that all of these systems are as easy as possible for humans to control, as many as we can. So that's the start. And does it eventually get to the point that you're talking about? Yeah. Totally possible. So
Brandon, let's go to you, because among the different things that Brandon is, he is also a retired Navy SEAL. And one of the first things that Shield AI made that I covered, you created GPS independent little drones to go inside houses and figure out where everything is without having to receive a signal from a satellite constellation that is jammable. When you hear this, putting yourself back in the role of that operator that has to go in and do that, what are your expectations and what are your concerns? What are you looking for in terms of a AI assistant, like on the ground, or as you do, to take out that that standard missile battery that's over there?
Yeah, first and foremost, you want to trust the system, right? So there has to be a level of predictability in terms of what it's going to be doing. And that doesn't necessarily mean it does everything human-like, right? Definitely if it does do, for this quadcopter, if it was exploring a building like a human would, it gives you a certain amount of trust, gives you a certain amount of predictability, right? If we hop into a self-driving car, you're going to expect it to drive, like a good human would drive. Not like me, not a bad driver, but that trust is a big aspect of it. And so that's what you see, what that leads to is widespread adoption.
Yes.
And then from there, I think you'll start to see new and different ways where it starts to, do the novel tactics, technique, procedures. We saw this with our F-16 flights, where it would start to do things that human pilots wouldn't necessarily want to do or would do because of the level of risk that would be experienced by a human, right? And the same way, like a self-driving car, if you wanted to put it on a racetrack, it could do things that would make all of us very, very uncomfortable in doing. But as people begin to trust those systems more and more, I think you're going to see more freedom in terms of what we allow these machines to do.
Yeah, and that trust, that relationship of trust, that is a thing that is built every day. That is different from like, hey, we have created a solution for you. Here, you can go ahead and enjoy it. You can send us an email if you don't like it. It is that daily exchange of teaching the thing who you are and then what it is and how you collaborate. And yes, they can take that and then pump out updates across an entire constellation very quickly, but you're still building it. This is very different from the way, this sort of speaks to the strength of the US military, which is big trust in non-commissioned officers, exported that a little bit to Ukraine. The person on the ground needs to have understand the legal parameters of what they're going to do, but also have the autonomy to make the decisions that they need to make at that moment. And that is a real advantage compared to, say, a top-down bureaucratic thing where, Shoigu commands from Moscow and it turns out to look like crap, and so they have to retool everything. But Dave, let me take you for a second and ask, so we've talked a little bit about how increased autonomy on drones provides a kind of big challenge set for you. You also mentioned that one of your strengths from the defense side is those big compute resources that you can rely on. How are you looking at autonomy, and particularly, how are you looking at artificial intelligence right now to discover new counter-drone tactics in a way that you hadn't expected before, as Brandon was talking about?
Absolutely. So we oftentimes break the problem down. I mean, the Defense Department, defense industry, we love our acronyms, love all of that. But commonly, sense, decide, and act. You oftentimes think of AI kind of in that decision portion of that chain, but it really is moving forward, baked into all three. If we look at the sense portion, especially the size of these drones, how do you separate them from birds? How do you separate them from a grocery bag that is just floating through the air, all of that? Being able to do that and distinguish that and then have that come back to your operator in a way that is human understandable. Because you can't just show, oh, there are 1,000 potentially birds or drones in the sky. You need to bring that back down to the operator level, where they're actually able to see, all right, here are the highest priority ones. Here are the ones that are most likely to be a threat that maybe you want to take a look at. And then depending on what your defeat mechanism is, you can kind of appropriately tailor it to that. So AI is integral to every part of the chain, and I think that's true across the board.
Okay, so at Replicator 2, how is that changing what you're going to be asking for and expecting from folks that are showing up to test these things? And also talk to us a little bit about the testing and practice and exercising schedule for evaluating this as part of Replicator 2, because it's different from the way folks had been doing things in the past. Like you're kind of trying to accelerate that pace at which you can make decisions about what to buy and what's working.
Absolutely. So on the first one, in our low-cloud defeat solicitation that went out in partnership with every service, multiple combatant commands, multiple other parts of the Office of Secretary, because we do understand this is kind of whole-of-department effort, whole-of-department challenge. And one of the things we specifically said was we did not want just a library-based solution. Library-based, for people who may not be involved in that is I have programmed in every drone that we are aware of that is commercially out there, what frequencies it's using, what protocol it's using. Therefore, I'm just going to do a lookup table when I see something. That is not going to work in the future. We know we're going to continue to see things shift, change. Once again, you're going to have frequency hopping, protocol hopping, all of that is going to be occurring dynamically, and so you need solutions that are able to iterate at that pace.
Yeah.
Do you have follow up swiftly on that, or?
No. I was going to ask Brandon how you follow up on that, because that sounds like, they're anticipating your guy out there 24 hours later picking the thing up and sending it back. So how do you innovate against that?
How does Shield AI innovate against that? No, I agree with just that methodology, right? It is just going to be a pace of rapid change where these autonomous systems are learning, they're aggregating data, they're learning from it, and then, basically wanting to come up with their own solutions to problems that are cross-validated by rigorous testing evaluation from the human side of things.
So we're going to have, we've got time for some questions. Raise your hand. I think we got a mic coming around. But feel free to interact with us, because this is something that's changing the way if you all work. Oh, there's a question right there. This changes the way you all have to make things, the speed at which you have to make things, the person you have to make the thing itself. So go ahead, please announce yourself and your question. Thank you.
Paul Scheer, Accenture Federal Services. The advent of subsurface warfare and its effect on autonomous drones seems to me like one of the larger questions. Have you guys made any consideration on how you might operate drones inside of tunnels autonomously, or for that mapping element? Has that been a...
Yeah, so one, we've operated drones inside tunnel systems. Our drones were used to help rescue hostages in Israel on October 8th, 2023. Very proud of that. Comes back, I think you were calling it sense, decide, act. Shield AI calls it perception, cognition, action, right? But it's, these systems are sensing their environment just like you and I. They're thinking about what to do and then they take action. That is true in the space domain, in the air domain, in the land domain, on the surface domain, subsurface domain, water, land, air, wherever you're operating.
Wonderful.
Yeah.
Thank you.
There was a DARPA Grad Challenge a couple years ago to actually try and create autonomous and drone solutions for subsurface things. And this speaks directly to that. And that shows you that the domain of war is going to be happening in a lot more places than we're ready. Right here. Yes, please.
Hi, my name is Yulia O'Connell. I represent Dignitas Fund. We work at the front line in Ukraine, specifically with drones. We've been doing that for the past 2.5 years. When no one believed in drones, we started and trained over 150,000 people. My question is, right now, as we see the changes happening extremely fast, how DoD and I see Defense Innovation Unit, how the procurement is going to be happening? Because procurement right now, even in Ukraine, we have about 6 months when they are contracting drones. How is changing in DoD here when you know that it's, sometimes 2 years of procurement, sometimes they're trying to make that shorter, but who is advising? How is it happening in the United States right now, and what's the advice even for Ukraine would be?
Yes, David, who's your boss, and would you like to complain about them? This is a great question. It's very important. Please.
Absolutely. So DIU, one of the things, the reason a lot of the services partner with DIU within the department is because of our ability to move fast and to move at the pace of commercial industry and what we're seeing. And so our core contract vehicle that we use is the commercial solutions opening. And so for what I'm talking about with low cloud defeat, we announced that in May, looking to bring out the initial tests of the selectees in the fall to actually be able to get things out into the warfighter's hands next summer, which is still slower than what you're seeing in like Ukraine, but that is increasing the pace. And you've seen that from the secretary on down, trying to continue to push on that gas as much as possible to accelerate that, because we know that even the traditional DIU fast pace is not fast enough as we move forward.
Yes, please.
It pains me to compliment the Army as a Navy guy, but the U.S. Army is doing really amazing stuff in the world of acquisition that, I give a lot of credit to General George, General Rainey, Army Futures Command, and the Secretary of the Army. They're utilizing they're calling them directed requirements, where they're buying drones, AI, autonomy, via a directed requirement every 2 years. But essentially, they've outlined that there are certain capabilities that require, right, a traditional program of record, right? You wouldn't build an F-47 fighter jet on a 2-year directed requirement just because the capital expenditures required to build such an aircraft, and you'd want that lead time. But there is a subset of products, AI, autonomy, drones, which are rapidly evolving, and there's a wide recognition that the drone you buy now is going to look very different 2 years, 3 years from now, so we shouldn't be locked in to a 17, 20-year program of record to buy these technologies. And so what the U.S. Army has done is said, no, we're going to use directed requirements. We are going to the way that they're funding them right now, they're canceling programs. They canceled the FTUAS program of record for these types of drones because they said, we don't want to be in the program of record of business for these drones. We want to be in the business of buying these capabilities every 2 years. And I think you're going to see more and more of that adoption with the Navy, with Marine Corps, with SOCOM, with the U.S. Air Force.
Okay, so keep those hands up. Start thinking more questions. We don't have too much time left, but before I do, I want to go back to you, Dani, because you guys work with Special Operations Forces, and their model of acquisition is becoming more and more the model of the way everything else does it. But it's not like a perfect fit to just take the SOCOM model and stick it on a big force, because the reason they can move so nimble, is my understanding, they buy things at much smaller numbers, so it's a smaller amount that you got a contract for, so Congress doesn't have to get involved. And they can use a lot more dual-use technology. But talk to us a little bit about that SOCOM acquisition model and how you see it potentially scaling up across the greater force and where it can't.
So the reason that we target the joint forces specifically is because we know that goes across all of the different air, ground, all the things, right? So we know that that's the future. That's where we want to be. So that's really actually why we started targeting the special forces community first. It wasn't necessarily just about the acquisition. But I will say the biggest thing that across all of DoD is getting really smart about is using the open architecture, the MOSA, FACE, all those different types of things. It's not saying you must use this architecture, but it is saying you must use a standard protocol for sending messages back and forth and information. That is going to open up the ability for different new software to be able to be integrated into all different kinds of hardware because they'll have a set rule for all of the different sending of information back and forth. That is going to have a massive impact across all of DoD and being able to speed innovation.
Yeah. But the question is, can it speed it faster than the adversary? That's what we're working out. So we got a question back here.
OSD CDAO. In the spirit of rapid adaptation, rapid procurement, what do we need to do to accelerate T&E and AI assurance processes to make sure that we can innovate, responsibly, safely, securely?
That's a good question. T&E, yes. Like when you go to Ukraine, you're just like, hey, we'll send it that way and see if it works.
It is a really interesting question. What I'll say is that industry does T&E about 10,000 times faster than the US government does. And that is something that, needs to be acknowledged, needs to be recognized. But if we go out and test a new software patch on an aircraft, whether it's an F-16, whether it's our we'll stick with like our VBAT, which, we don't own the F-16s. We're testing that. When we go out to a range, we can go accumulate, and we'll fly multiple aircraft. We can get thousands of hours of flight in a really rapid cycle. Call it like a month. We'll accumulate multiple thousands of hours of flights. Yeah. You do a flight test event with U.S. government, it's painfully slow. There's got to be staff members on board, and like you might only be running one site versus many sites in parallel. And so you might accumulate 100 hours because they had these certain test wickets. And so I do think there needs to be an acknowledgement of industry in terms of what they're bringing to the test and evaluation table, in saying, yes, that's okay. We can use this data. We understand what this partner did in terms of their testing and evaluation, simply because it's going to happen at a much faster pace than the government can keep up with it. Again, I do think there have to be government test and evaluation milestones for capability. They should be, checks, but the U.S. government, everybody should be saying, what's your test and evaluation policy? Like, industry, what are you doing here? Show me. We want to be a partner with you guys. We want to work together. But again, I think there's got to be, the government shouldn't own test and evaluation, which I would claim it traditionally has in the past. And industry would simply do what the government is asking. That paradigm has shifted to industry saying, we're doing test and evaluation at a pace that we're accumulating way more data faster, and there should be recognition and acknowledgement that that data, all that testing and evaluation that has occurred, should be used to validate the system by the U.S. government.
David, you are government. So how do you, what do you think of this idea of sort of relinquishing aspects of test and evaluation? Can you have credibility in industry-provided data in a way that allows that acceleration?
So I do think there's a larger kind of rethink of kind of the paradigm. Traditional test evaluation, you go through, and at the end, someone kind of blesses that final solution, and here's what you're now going to field for the next decade. You're still going to have some of that, but you really do need to move more towards a continuous development approach. How are you continually getting these things in the hands of warfighters, having that feedback that then feeds back to the company, where then 24 hours later, they can give you an improved product. Actually, that's why DIU just recently announced our Project GI to try to get some of these autonomous systems in the hands of warfighters earlier to close those cycles much more rapidly. That doesn't fully address test and evaluation and some of the concerns that I think are very fair. But definitely agree that we need to be shortening those innovation cycles and having test and evaluation as a part of that.
Can I add just one more thing on the T&E side? One of the things that industry does, I would claim better than government and DoD, is that they accept failure and move forward from it and understand that failure is a learning lesson, right? And so I would use the example, and this is, SpaceX does partner with the government, and I think they've got a good relationship. But if SpaceX was crashing Starship, as they have been, and were part of a government test and evaluation program, that thing would be frozen for 9 months. People would lose faith and confidence in the program, and they'd say, you know what? I'm not really sure about this capability moving forward. We've crashed 2 Starships. These are big things.
Yeah.
It's, industry, right? SpaceX and other people in industry are saying, no, we're learning a ton. Right? We know that because we're going fast, we're going to make mistakes. We are going to fail. We are going to learn from that. Example in Ukraine, had we, done that with the U.S. government where it flew away for, this period of time, people would have said, you know what, we need to go back to the drawing boards. We should spend another 4 months doing an investigation into what happened. Meanwhile, right, we say, great, we learned from this. Let's send the patch. Let's move forward and continue to iterate.
Yeah, Dani, you had something on this.
I did. So actually, the OSD, the Chief Digital Artificial Intelligence Office, has a program for the Responsible AI Toolkit where they are doing their best to help kind of figure out what is that right level of documentation that needs to come from industry T&E to the government so that they can actually look at it and say, yes, I think this is great, to your point about being able to just like bless it. That's what they're actually trying to do. They're trying to do that in a way that is fast and reliable and repeatable. And actually Primordial is working with them to kind of figure out what is that level of documentation, how often, how does it look, and what is the form that needs to be given to a military commander to say, yes, I trust this.
Yeah.
I get past your like techie words and I actually, yes, this can go in my AOR.
Yeah, that's fascinating. Like, this is the same thing that Silicon Valley and all of our great sort of like digital companies have been using for a long time. Can you imagine in like 30 years ago, the idea, I'll just go to some random person's house rather than a hotel room? It's insane. That is an insane idea. They think that thing only works because there is verification, there is a sense that data has been collected, that it is trustable to speak to your trustability as a potential occupant and that person's living room as a place you might want to be and that person as a potential landlord. That's impossible otherwise. We got one right here. And then we have one in front too. Yep. Okay, one right here. Yeah.
Hi, Chris Aliashway, Buzan Hamilton. The panel mentioned earlier how there is no durable advantage for any capability. What are some of the future trends you're thinking about now so you can proactively address them in the future?
Yeah, so we're seeing trends across multiple different areas, but method of manufacture. So traditionally, kind of COTS drones, that allows you to do kind of library-based defeat. We are seeing easily modified with either a 3D printer or entirely 3D printed, those types of drones. Drones are getting faster. They're no longer using dedicated bands. They're either operating in LTE or Wi-Fi or not using any radio at all. They're able to navigate more and more autonomously. You do see operating in either multiples or in coordinated swarms. There are a host of ways that we're kind of seeing the threat evolve, thanks to people like Brandon and Dani up here, and others.
Yeah.
Yeah, just one thing. When I look at autonomy or physical AI, as a NVIDIA or a Tesla would call it, I think, it's going to be one of the most transformational technologies in the next 50 years. 2, I would claim that it's like, if I use an analogy, it's where the state of AI and autonomy today is basically where the internet was in like 1997, right? And you think about like what the internet became from 1997, to where we are today, that I actually think there's a ton of room to run with physical AI, with autonomy, right? Self-driving cars, humanoid robots, self-driving fighter jets are really like tip of the iceberg. There's going to be really incredible innovations that are coming out of this space on the backbone of this transformational technology.
Okay. All right. It's very exciting stuff. A lot of people were very excited about self-driving cars, but when you think about an entire constellation of them, you create a obsolescence around the idea of parking. And then if you don't have to worry about parking your car because it can come a mile away, predict where you're going to be, drop you off and go back, you don't have parking tickets, and that's how we pay for schools in cities. So keep these in mind. Some of these trends, they have effects far beyond the immediate market niche. But with that, I'm being told we are shortly going to move into our next panel, Fraud as Battlefield, with Jordan Burris and Robert Shea. But in the meantime, thank you all. We had more questions than we had time to get to, but stick around because they'll be here and we'd love to hear from you. Please join me in thanking the panel here today.